Hey everybody, what's up? This is my first ever live stream, and I've been asked by a student of mine to write a Python program that basically prints out the first n prime numbers. So what I'm trying to do is make a program where if I type in n equals 50, it's basically going to go ahead and print out the first 50 prime numbers for me. So this is going to be a bit of a mathematical challenge as well as a programming challenge. It's quite an interesting problem actually, so let's see if we can do it. Let's go ahead and get started. The first place I'm going to start is by writing some sort of script that is going to check whether any number I give it is a prime number or not. I think that's going to be a good place to start. So what I'm going to do is, let's first remind ourselves what a prime number is. A prime number is any number that can be divided equally only by two numbers, 1 and itself. So for example, if we want to check whether the number 50 is a prime number, we would first divide it by 50, which gives us 1. Then we would divide it by 1, which gives 50. And then we need to check if there's any other number that fits into it equally. And there's loads of numbers that fit into it equally. There's 25, there's 5, there's 10. So 50 is not a prime number because there are numbers other than 1 and 50 that fit into it equally. So let's try something like 7. So we know 7 divided by 1 is 7, 7 divided by 7 is 1, but there's no other number that fits into 7 equally other than these two. So we can conclude that 7 is a prime number. Now this is important because we basically need to, everything we've just discussed right now, everything we've just gone through, that logical thought process, we need to translate that into a program. We need to translate that into a step-by-step procedure that the computer can follow. Let's create a number. X is equal to 7. Let's start with that. Now for me to check whether this is a prime number, I need to see if there's any number other than 1 and 7 that fits into it equally. Now the way to do that is through a certain operator called the modulo. Now the modulo, which is usually given the percent symbol, is an operation which is quite interesting because what it does is it basically gives you the remainder of a division operation. So say for example I do 10 modulo 5. What are we expecting this to be? Well, we just need to see what the remainder of 10 divided by 5 would be. So if I do 10 divided by 5, I know that 5 fits into 10 equally twice. So really the remainder should be 0. Let's see if we do actually get 0. And as you can see, that is the answer. But if I try doing something like 10 divided by, or 10 modulo 7 rather, well, 7 fits into 10 once, and the remainder is 3. So really this should give me 3. Let's try that, and the answer is 3. So this modulo operator is going to be absolutely crucial. Let me tell you why it's going to be crucial. I'm going to get rid of these cells for a moment. Run that one more time. So the reason the modulo is going to be crucial is because a prime number will only give you a modulo of 0 for two numbers, 1 and itself. So there should be no other number that will give you a modulo of 0 if your number is prime. So we can basically go through a list of numbers and try a division process, and if at any point, if at any number we get a modulo that is equal to 0, that means that number is not prime. So let me give you an example. I'm going to say, for example, p is equal to 10, okay? And I want to see if 10 is a prime number. So I'm going to ignore dividing by 1 and dividing by 10 because I know those numbers fit into this equally, so we can ignore those. We don't need to worry about those. Let's try other numbers. So 10 modulo 2, well, that gives me 0 as well. So immediately we can tell 10 is not a prime number because there's a number other than 10 and 1 that gives a modulo of 0. So if we try, for example, another number, let's try q is equal to 13. So q divided by 1 is going to give 13. Q divided by 13 is going to give 1. We can ignore those two. So let's try other numbers now. So let's try q modulo 2. That is not 0, which is good. Let's try q modulo 3. That's also not equal to 0. Q modulo 4. Again, not 0. Q modulo 5. Not 0. q modulo 6, not 0. And I'm going to do one more, and I'm going to show you something interesting. So I'm going to do q modulo 7, and this is also not equal to 0. So the question is, do I need to carry on and try a modulo 8, modulo 9, modulo 10? And the answer to that is actually no. You don't actually need to go further than half the number itself. So the number we're looking at is 13, right? We're looking at the number 13 here. So I can go through this list, but where I can stop is 7 over here, because 7 is the rounded up half of 13. I don't need to go any further. And the reason for that is, if I go any further than 7, I know that that number will always fit into 13 less than twice but more than 1. Think of any number greater than 7 but less than 13. How many times will that go into 13? It will go once and some more, but it will never reach 2. So if it's once and some more, that is a decimal number, it's not an integer, which means it will not help us figure out whether the number 13 is a prime number or not. So the moral of the story is, if we're looking at any number, say, let me delete these. So let me delete these cells. If we're looking at any number here, this can be, I don't know, 151. We only need to go to half of this list rounded. Half of the list of numbers from 1 to 151 rounded. So that would be 151 divided by 2. So let's try that, 151. Let's round. 151 over 2. And what does that give us? 76. So we only need to check from 1 to 76. And if within 1 to 76 we don't find any modulo equal to 0, other than 1 of course, then we can conclude that this number is a prime number. So now we've got an interesting logical thought pattern that we can translate into a computer program. So let's go ahead and get started. So I'm going to delete all of this and start with 7 once more. So what I'm going to say is, first I'm going to create a list that goes from the number 2, because remember we're ignoring the number 1 now, because we know 7 divided by 1 is 7, so it's a useless thing to include into the logic. So we're going to start from 2. So we're going to say, for I, I'm going to create a loop here. For I in range, let's start from 2, and we're going to go to the rounded 7 over 2. And a crucial thing here is to add a +1, and the reason for this is, round 7 over 2, if I put it inside a range statement here, or a range function rather, Python will stop at 1 less than this final limit that I put here. It's just the default way Python does things. So I'm going to put a +1 here to sort of balance that. So I'm going to put a colon here. Oops, I wasn't meant to run that. So let me copy that and delete that. Let's try again. So what am I doing here? So I want I to start from 2 and go all the way up to half of 7 rounded. Every time it goes through the loop, I want to check if 7 divided by that number gives me a modulo of 0. So if 7 modulo I is equal to 0, then I can print, let's try it like this. Let's convert x to a string, otherwise it won't print. And let's say, I don't know, something like x is not a prime number. And the reason it's not a prime number is because there's a number other than 1 and itself that is giving a modulo of 0. So that's what's going to happen if we do find something that gives a modulo of 0. And what I want to do now is, what if 7 modulo I is not equal to 0? Whoops, not equal to 0. What do I want to do here? So let's think about this. If it's not equal to 0, then I don't really need to do anything. I just need to check the next number. So how do we terminate this? How do we tell Python when to stop looking? So we're going to tell Python to stop looking exactly when it reaches this number here. So when Python starts from 2, it goes to 3, then 4. This is where 4 is. So 4 is the limit of this particular list when x is equal to 7. So if I is equal to 4, I basically want to stop looking now because I've gone through the list and I haven't found any modulo that's equal to 0, so I can stop, right? So I can say, I can put another if statement inside of this. So I can say if I is equal to rounded 7 over 2, then print, again, string x is a prime number. And I forgot to put this in quotations. So let's put this in quotations and let's put a space here. Otherwise, it's not going to print very nicely. And I just realized I've made a mistake on all of this. I shouldn't be putting 7 here. I should be putting x here because we already said x is equal to 7. So let me correct that. And with any luck, if we run this, we should get this printed statement because obviously 7 is a prime number, so that's what we're hoping to see. So fingers crossed. And look at that. So it's told me that 7 is a prime number. So let's go ahead and recap what this has done here. So it started from 2 and it's gone through the list of the half of 7 rounded. And we've done two things here. In the first condition, we've said if 7 modulo I is equal to 0, then it is going to tell us that it is not a prime number. And I made another mistake. I can't believe I did that. This should also be x. I do apologize. That should also be x because now this is completely symbolic because we can change x to whatever we want it to. Okay, so where was I? What was I saying? So when we are in this part of the logic, we are checking if the modulo gives 0. And if we ever find 0, then it's not a prime number. So if we don't get any zeros, and if we reach the end of our list, which is this upper limit over here, then we can conclude that we have found a prime number. So let's try something now. Let's try a number that we know is not prime. So let's try something like 10. And let's run this. So at first glance, it seems to have worked. It's told us that 10 is not a prime number, which is good. But why is it telling us twice? So let's see. This is telling us twice because, well, it's going through the loop. And so that means it must have found two numbers in this range. It must have found two numbers in this range that fit equally into 10, which is true. It's going to have found 2 and 5. And that's why it's printed this twice. So what that means is that, okay, so here's what we can do to fix that. It's a very simple fix. What we can do is we don't want it. Once it's found a factor, so once it's found a number that gives a modulo of 0, we don't want it to continue looking because we know it's not a prime number anymore. So we can tell it to stop looking. And the way we can do that is just simply put a break statement here. So this will, once it's found a factor, this will basically immediately exit out of the loop. So let's try running that and see if that fixes the problem. And yes, it does. So it's only giving us a single print statement now, which is good. So we've basically just made our prime number checker. So this little logic over here, this statement, this for loop rather, is going to check for us whether any number we give it, in this case x, it's going to check for us if x is a prime number. So let's try something else. We know 13 is not, it is a prime number, excuse me. So let's see what that tells us. And yes, it's telling us that 13 is a prime number. I'm going to put a full stop here because it looks nice. Okay, and that's it. So that is the first part of our objective reached. We now have a small little program that can tell us whether a number is a prime number or not, because that's going to be a crucial part of what we're trying to do. All right, so the next thing we're going to do now is we've got something that checks prime numbers for us. What we can do now is we can make a function out of this. And the reason we're going to do that is because we're going to need to check multiple numbers. We're going to need to check lots and lots of numbers. So it's not going to be feasible for us to come here and type in the number every single time or run this cell and then run this cell every time we want to check. So we're going to put that into a function so we can call it through the program as many times as we need to. So that's really easy to do. I'm going to come over here and type in def, and let's call this let's call it prime number checker. and we're going to give it one argument, which is the number that we wanted to check. So let's just call it num over here. And I'm going to indent this. And what I'm going to do here is I'm just going to say x is equal to int num. And this is always good practice because we don't know when we call this function could be called with anything here. It could be the number 1 as a string. It could be number 1 as an integer. So for example, if we were to use a text box or an input field, which is what we're going to do later, if we were to use an input field, it will transfer the number, this number, it will transfer as a string. So if we pass a string into this whole calculation won't work because this is expecting the number to be an integer. So this line is always a good housekeeping measure, just to make sure that the input that we've got is exactly the input that the rest of the function is expecting. Okay, so, and we can actually get rid of this one now. We don't need that anymore. So let's run that. Okay, good. So there's no errors. Now let's check if it works. So I'm going to check if the number 41 is a prime number. So I'm simply going to type in prime number checker, if I can spell that, and let's give it 41. And there you go, 41 is a prime number, and it certainly is. Alright, so let's go ahead and make our function a little bit smarter. And let me tell you why we need to make it smarter. Let me say, for example, prime number checker. And let's put in here the number 1. Now we know number 1 is not prime. I think there's some debate about whether it should be a prime or not, but we're going to assume in this case that it isn't. So let's see what happens here. It wasn't able to give me an answer. So it's basically gone through this whole thing and it wasn't able to provide me with an answer. So it doesn't know whether 1 is a prime or not. So why is that happening? Well, let's follow this function here for a second. Let's imagine we've put the number 1 here. So the number 1 is coming here. And if we look at this now, imagine we put 1 over here. 1 over 2 is 0.5. Round that up is going to give 1. And 1 plus 1 is 2. So I'm basically telling Python to create a range starting from 2 and ending at 2. Well, that's not going to create anything. So there are workarounds to this. You can sort of make this smarter, but I'll tell you an easy way we can fix that, because honestly, I don't think it's going to be worth much because we know 1 is not a prime number. So that's a given fact. We don't need to get a program to check that for us. We can simply hard code that into this. So let me show you how we can do that. So we're going to say if the number that we've got as an input is exactly, excuse me, we don't want num here, we want x, because this is after it's been converted to an integer. So if x is exactly equal to 1, we're going to print x string x plus, and again, we're going to say the same thing, is not a prime number. Okay, cool. So then what we can do is the rest of this logic that we've got here, this for loop, we're only going to execute this if the input number into this function is not equal to 1. So we can say else, and this should cover everything. Okay, so let's see if that works. So now let's run prime number checker again with 1, and there you go, 1 is not a prime number. Cool. Now what I'm going to do is let's try another number. Let's try 2. Now 2 is a prime number. So if we run this, well, what do you know? It's basically not able to give me an answer for this either. So why is that happening? Well, you can bet it's for the same reason here. It's creating a list with basically 1, or in fact, I believe it's nothing. Actually, no, I think there'll be 1 item in this list that it's creating, but that's not enough for it to determine anything. That's not enough for it to determine whether it's a prime number or not. So what we can do here is, we know 2 is a prime number. That's a given fact again. So what we can do is simply create another hard-coded else statement. Excuse me, that should be else if. So if x is equal to 2, we can print string x is a prime number. Okay, cool. And let's run that, and let's run this. So it should work. Good. And now let's try 3. Let's see what 3 does. and it's found that 3 is a prime number. Let's try 4. 4 is not a prime number. So now this seems to be working pretty well because we can start from 1 and we can go all the way up to whatever number we want to. And this is reliably telling us, this bit of code here is reliably telling us whether this is a prime number or not. So we're getting there, we're getting there. Let's remind ourselves what we're trying to do. We're trying to create a calculator, an app if you like, where if we put in 50, the computer is going to generate the first 50 prime numbers for us. So we're not quite there yet. The reason we're not there is because at the moment we've simply got a checker. We've got a function that checks whether a number is prime or not, but it doesn't actually produce a number of prime numbers that we want. So if we want 50 prime numbers, this function is not going to do that for us unless we go manually and try doing it ourselves. So that's not the best way to do it. That defeats the purpose of having a computer program if we're having to do so much manually. So let's go ahead and think about how we're going to do that. So the way we're going to do this is, well, we can create another type of loop called a while loop. And what that is going to do is it's only going to continue looping while a certain condition is met. Hence why it's called a while loop. So we can actually do something cool with that. So what we can do is, well, let's try a simple example. So what I'm going to do is I'm going to say while. Actually, before I do that, I'm going to initialize the condition. I'm going to say x is equal to, let's just say 50, and y is equal to 0. So I'm going to initialize these two, and let's try making a while loop here. So I'm going to say while y is less than or equal to x. So what I'm going to do now is I'm going to say, I'm going to call the prime number checker for y. And actually, I'm not going to start at 0 now that I look at that, because 0 is a bit complicated. Is 0 a prime number? Is 0 not a prime number? I'm not going to go into that. I believe it's not, but let's just start from 1 to make our life simpler. So what we're going to do is, while y is less than or equal to x, we're going to call the prime number checker on the number y. So because we've set y equal to 1, this is going to start with checking the number 1. So in the next loop, we want it to move up to 2, and then in the next loop after that, we want it to go to 3. So what we want to do here is tell Python that once it's checked y, we want to add 1 to it before it checks it again. And it's going to keep doing this, it's going to keep doing this, and what's going to happen is once it reaches y is equal to x, which is 50, then it's going to stop. So this is now going to check the numbers 1 to 50, and it's going to tell us which one of those are prime. So let's hit run. Hopefully it works. Okay, so let's take a look at this. I mean, I don't have all the prime numbers memorized, but this seems to be okay. So there's 2 and 3 here. Let's just do a quick check here. 5 is good. 17 is good. 17 is good. Let's try 23. Yep, that is good. Let's try 41. Yep, that's good. 43 is also a prime. 47 and so on. And these, of course, are not prime numbers. So this seems to be working. I'm pretty sure this is right. I mean, you can always take a look at a list of the first, I don't know, whatever prime numbers, and this should match up with this. But if you look at this is not very helpful. It's just too much. There's too much writing here. So we're going to need to do something about that. We're going to try making this a bit cleaner, because at the end we just want a list of the first 50 prime numbers. We don't want any of these words here. It was useful before while we were trying to build the program, but I don't really think we're going to need it anymore. Okay, so this seems to be working. Now what we're going to do is we're going to create another condition here. And what that condition is going to do for us is, let's see, we want that condition to keep increasing. So let me make a new number here. Let me just say counter is equal to, actually this is the number n. I just realized that. So this is the number we're after. So let's just say n is equal to 100 here. So what are we trying to do? What we want to do is we want to check if a number is prime. And if a number is prime, then we're going to count. Excuse me, I think I need another counter here. So I think I do need a counter actually. I'm going to say counter is equal to 0. Yeah, that makes sense now. So let me try that one more time. I kind of lost myself there. So here's what we're going to do. We're going to start from y is equal to 1, and we're going to keep going. We're going to keep going, keep going, keep going. We're going to keep increasing y up until we have reached an n value that we are happy with. In order to do that, this n value is going to be input into the program. I'll show you how we can do that in a minute. So the way we can do that is we need to check whether this number is prime. Now our calculator does do that. This function does do that, but it keeps printing out all this stuff for us. We don't really want this anymore. So I'm going to go ahead and I'm actually going to comment these printing statements out. And I'll show you what we can do instead of doing that. So let's go ahead and get rid of all of this. So what I want to do is, if it is a prime number, I want the function to return 1. I just want it to return the number 1, which means yes, it is prime. And over here, it's not a prime, so I'm going to leave that. Over here, I'm going to say return 1. Now, the reason we're going to do that is this allows us to check in a quicker way whether we've got a prime number or not. So let's go ahead and see how we're going to do this now. Okay, so what we can do now is to move along further with this. What we're going to need to do now is change some of this stuff. So we're going to say while counter is less than or equal to n, because now we want our program to keep going until we've got n prime numbers, which is exactly what we're after. So what we're going to say is we're going to declare another variable here to store the returned value of this function. So we're going to get it to return a value here, which we are doing over here. If it has found a prime number, it's going to return 1 over here, as you can see. So what we're going to do is we're going to say, I'd have no idea what to call it. I'm just going to call it yes, no, prime, and I'm going to say this is equal to 0. So I'm going to say yes, no, prime is equal to the value of this function. So here's the logic now. We need to check if yes, no, prime is equal to 1, because if it is, then that means we found a prime number. So we're going to say if yes, no, prime is exactly equal to 1, we can increase the value of counter, because we don't want counter to increase every time we run this loop, because that's not going to help us. We only want counter to increase once we have found a prime number. So that's a little bit different. Okay, but what we need to do now is we also need to set some condition for y, because at this stage it's not going to do anything. Y is not changing in this loop, so we need to fix that as well. We want y to change every time this loop runs regardless. So counter is only going to change if it's found a prime number, but y needs to change regardless, because y needs to keep going. It needs to keep going until this condition is met. So what I'm going to do is over here, I'm going to put y plus equals 1. So what this is going to do is just going to start with y is equal to 1. I'm going to get rid of x over here because we don't need that. We need n, and we need the counter, which is good, and we need yes, no, prime, which is good. This eventually will be put into the software with a user input, but I'll show you how to do that in a minute. So let's go through the logic here. While counter is less than or equal to n, and counter is starting from 0, which is good. If yes, no, prime is equal to 1, then we want the counter to increase. And otherwise, it's going to, but regardless of that, it's still going to increase y by 1. So this seems like it's going to work, but there's one little problem here. We're not creating a list of the numbers that we're finding. So what we need to do now is modify this a tiny bit. Let's create a list of primes, and let's give it an empty assignment for now. So what we want to do is, if it has found a prime number, so if it's checking y and it finds that y is a prime number, then we want to add y to a list. And we can do that with appending. So we can just say list of primes dot append y. And of course continue to do that. And then y plus equals 1. So this seems like it should work. Let's try a smaller number here. Let's try n is equal to 10. And let's see, fingers crossed. Okay, so there's a problem here because I did not run this cell, I believe. So let me cancel that. And let's run this cell one more time. Okay, there's a problem here. Let's see. What's the problem here? Expected an indented block. So why is that not happening? Okay, I think that's because nothing is happening here. So we can just tell it to pass. We don't need to really worry about that. Let's see if that fixes the problem. Yes, it does. Because if x is equal to 1, we just don't want it to do anything. We could tell it to do something, but because previously we were printing stuff, we're not printing anything anymore, so I don't really think it needs to bother with that. It's just going to skip over it, and I think that should be fine. So let's see if this is going to work for us. Okay, so it seems to have worked. It has run, so let's now, fingers crossed, let's print out the list that we've found. List of primes. And look at that. How cool is that? That's actually worked. So hold on, 2, 3, 5, 7, 11, 13. Yeah, these are all prime numbers, definitely. And let's see how long this list is. Is it really 10 items long? So let's print the length of list of primes. And it's actually 11. Okay. There's a quick fix to that, of course, we can just simply put n-1 here, and that will fix the issue for us. But you know what? I think I'm happy with that. I think that works. There's obviously a +1 happening somewhere, and I think if we go through this program, we could find it. But to be honest, this is such a simple fix. I don't think it's worth spending more time trying to make this smarter or to try and find a more creative way of doing it. It works, so why not? Let's just leave it like that. So we are now almost there. We're almost there because we've got a program which, if we give it the value of n, it's going to produce that many prime numbers for us, which is exactly what we're after. So let's make this a bit nicer. Let's put this into a function as well. This whole bit over here, let's put this into a function. And then let's allow the user to input a value of n and have the program print out that many prime numbers for us. So let's try that. What we need to do is we need to say n is equal to input, and let's say here enter the value of n colon, okay, right? And what we're going to do now is we're going to create a function, and we're going to call this prime list maker, and we're going to put in the value of n here. And we've run into the same consideration that we had to make last time, which is the fact that over here n is going to be a string, so by default we are passing a string into this, but this whole program requires n to be an integer. So let's convert n to an integer here, and I tell you what, I can't be bothered to go and change n over here. So what I'm going to do is I'm just going to call this num is equal to input, and let's put num over here, and then I'm going to say n is equal to the integer num, and that should be no problem. Okay, and that's good. So we can now initialize all of these things here. We can also bring y over here, so y should be inside this. We can delete this, and then what we can do is we can take this and let's cut that out and put this into a new cell. Let's put it here. And then what we're going to do is we are going to, once we've captured the input, we're going to call our prime list maker function with num. Okay, let's see if that works. So I'm going to run this one more time, run that one more time. There's an error. So what's the error here? Okay, I forgot the colon there. My bad. Let's run that. Seems to be okay. And now let's see if this bit works. So it's asking for an input. Fingers crossed. Let's say 10. Enter. And it hasn't done anything. Well, it's gone through the program, but okay. Well, we haven't really told it to print. We haven't really told it to print the list, so we can tell it to do that right at the end. We can say print. Let's say let's try it like this. The first plus string n plus prime numbers are. Okay, and then we can tell it to print the list of primes. Cool. So let's run this one more time. Let's run this one. And let's run this. What is the value of n? Let's try 10. And look at that. That's cool, right? That is pretty cool. I'm quite happy with that. Let's try running that one more time. And let's try 50. And let's just make sure that is correct. So I'm going to put over here, let's just see if that list is really 50 items long. It should be. Print the length of prime list. Excuse me, that's not the one. List of primes. And yeah, that is 10. Okay, so it's not actually going to do that because list of primes is local inside this function here, so it's not going to exist outside, so that's not going to work. What we can do instead is just, for now, we're going to get rid of this, but we can just for now put it here. Print the length of the list of primes. Okay, so let's type in 50. And yeah, it's telling us that it's exactly 50, which is what we're after. So we can go ahead and get rid of that. And we can run this one more time. And what we're going to do now is I'm going to type in the first 100 primes. Okay, so this is the list of primes that we've got now, the first 100 primes. And what I'm actually going to do is I'm going to go online and check if we've actually got the right numbers inside the list here. So let's jump online and let's type in first 100 prime numbers. And let's see. Hopefully it's in a nice list here. Yeah, whatever, come on. Okay. Yeah, all right. So the first 100 prime numbers, let's check where it finishes. It finishes at 541. So let's see where our list finishes. Our list finishes at 541. And yeah, so that's a pretty decent check actually, because if the first few numbers and the last few numbers are the same, you can bet all the ones in the middle are also going to be the same. Thanks very much for watching. Be sure to like and subscribe for more, of course. And if you want any more Python tutorials on anything, or if you've got another challenge for me, go ahead and let me know, and I'll try my best to solve it in another live stream. So thanks very much, and I'll see you next time. Bye for now.